And if you accidentally did O because I wasn't clear, and that is always very possible. I'm never clear. Then just write down the problems we work out on the board and then just submit that and you'll get full points. So real quick, a few people, let's see. Mike, you know you have this to make up with me, and the Cooper who's not here, and Kyle, you have the yellow one, and Olivia, you have the yellow one, Hannah, you have the yellow one, Riley, you have the yellow one. That's the calculator one. And then who else in third period? Flipping through third, eighth period. My goodness, I don't think I teach anything in eighth period. No one's done anything. There. Logan, you have the green 9 F through K to do. Grant, you have quiz 9 F through K to do. Peyton, you have quiz 9 F through K to do. Olivia, you have quiz 9 F through K. Olivia Chung. And let's see, Parker, you have quiz 9 F through K. And Landon, you have quiz 9 F through K. And is there anything else that is amongst the? Grant, you have quiz G through J, which is the unit trig quiz. And Cooper, who's not here, but I'm sure he's listening online, he has 8 G through M quiz to do. And Blake, you have 8 G through M to do. And then Cooper and Blake, you both, there's 2 parts to that. So, and that's about all I have. Now we're all caught up. So let's get those made up by sometime. I am happy to announce that the quiz from yesterday went pretty well. Goodness.
What was the average that you've had so far?
6. So it was out of 36 points, and the average was like 34.
Oh.
So I got to go back and readjust the grade. I can't have grades that high in here. It's just unheard of.
You should COVID.
Other teachers will start saying that I'm, not teaching or something like that. And yes,
are they going to take attendance at that assembly?
I will. I'll take attendance. And you show me that you're there by bringing a jelly donut. I'm just kidding.
Can you bring
We can throw jelly donuts at it.
Yo, we should
see a bunch of freshmen sitting in front of us. I'm just kidding. We were all freshmen at some point. I was freshman like 4 years in a row. Just couldn't figure it out. Hey, I went to kindergarten twice too, so deal with that one. So just a word of warning, so you don't walk into some shock. I wrote each and every one of you a postcard, just a nice little postcard. So if you get home and your parents are like, or your guardian say, "Hey, you got a letter from your math teacher."
You're like, yeah.
It's actually a pretty good one. But I think it's a pretty good one. I just want to, I know y'all get everything to you on your phone, so I decided to go old school and support our United States Post Office. And so you'll have a, so either today or tomorrow, you'll have one. And if you didn't get one, it's not because I didn't write you one. It's because I will just say the Pony Express sometimes screws up. So please let me know if you did not get one, and I will be happy to get you a second one.
Mr. Stirrup, what's a post office?
It's a building.
It's those abandoned buildings you see on the side of the road.
Yeah. So if you get home and someone tries to scare you, saying, "Hey, you're in trouble. You got a letter or a note from your teacher," then that's what it is. So just try and take care of each and every one of you as best I know how to. But those are a few things. So let's take a look at worksheet 11A. And again, if you accidentally did 11.0, instead just copy down what we do for 11A and just turn in 11A today. You should be fine. And I shouldn't be anyone losing sleep over it. What kind of questions did you come across on 11A? Go ahead.
8 and 13.
8 and 13. So let me do 8 first, and then shout out 13 to me when I get done. Number 8. we have x squared plus 2x minus 3 over x plus 2 times x squared plus 2x, and then I get 1 minus x squared. Okay. So when we're dealing with these, we're multiplying fractions, and these are ridiculous fractions because you have like quadratics in there and stuff. Make sure you factor it. You cannot just cancel like a little piece to a little piece. It has to be an entire factored term. So this top part would factor down, I believe, to x plus 3 and x minus 1. Would that be okay? And then is the bottom factored? Yeah. So the bottom's already broken down. So I would think this is good practice. So you feel good that that's factored, yes? Does everyone feel good about that? Put this in parentheses. And then you'll cancel out a grouped thing to a grouped thing. Does that make sense? And then over here, this is going to factor down to x and x plus 2. So obviously you have a monomial. You don't have to really worry about putting that in parentheses. But any of your binomials put in parentheses. Or if like a whole term won't factor out, put that whole thing in parentheses. That'll kind of let you know. And then the little trick on this one, this is kind of goofy. I'm going to pull a -1 out, and I'm going to do this. Now, see what I did here? If I distribute this negative back in, I'd get negative x squared. That works. And negative times -1 is positive 1. So I just flipped it over. That's a little tiny trick. A lot of times they put out there to you. And if you, granted, 1 minus x squared will indeed factor out. But sometimes it's harder to realize what's happening with that. So I'm going to move this down here. And then x squared minus 1 factors to x plus 1 and x minus 1. But please remember you have this negative here. Okay? All right, so now I'm going to start canceling out things that are grouped or monomials. So I can go anywhere on top to anywhere on bottom. So I have an x minus 1 here, x minus 1 here. Is that okay so far? I have an x plus 2 here and x plus 2 here. And then it doesn't look like anything else is going to factor out. So move this negative to the numerator. So I get negative x. So that moves up because I had that. And then I have x plus 3 as well. And then we've already taken care of that, so let's not worry about it. And then we have this. Bless you. So that's our reduced fraction. Okay, so there's kind of a lot of oomph to it. You said 13? Yes. Okay. Can I move off that board? Good? Okay. Number 13. Let's see. We get 2x squared minus 2 over x squared minus 6x minus 7. And then times x squared minus 10x plus 21. And I'm actually going to write that without parentheses. But I'm going to add this little part to it. Is that okay so far? The reason I do that is so you can see it as you have a numerator or denominator on the right side. Does that seem okay? So let's go ahead and do our factors. This first one is going to factor to 2. And then if I factor 2 out, I get x squared minus 1. So that's going to be difference of 2 squares. So I get 2, x plus 1, x minus 1. Is that okay? And then here on bottom, that's going to factor to x minus 7 and x plus 1. And up top, I'm going to get x minus 7 and x minus 3. And that's just going to be over 1. And that, again, allows you to realize you have tops and bottoms or numerators and denominators. So we're going to cancel out entire groupings. Okay, so I have, let's see, x minus 7, x minus 7, x plus 1, x plus 1. Nothing else is going to reduce. It's all going to be over 1, so we don't have to keep it over 1. So we're going to have an answer of 2, and then x minus 1 and x minus 3. And again, notice I'm not remultiplying it back together. I'm keeping it as a factored form. Okay. Hi, Kate.
Hi.
Hi, Kate.
Hey, dude.
Hey.
Oh.
That was really awkward.
What else would you like to see off of 11A?
Why would you do that? Why would you do that?
Oh, it's on your
Get
leg.
it?
It's on your leg, Kate.
What is it?
It's a
Spider.
Oh, that's awesome.
She found a spider.
That's the
And now
best.
it's friends.
Get the. Nope. No.
Oh, that's starting to sound really good.
Anyone give me $1, I'll eat it.
I got $1.
So how'd you get an extra $700? I ate a spider.
Get it away. And I have to bite you.
All right, what other questions do you have other than the spiders?
I don't want to sit back down. I'm just gonna put it like down my shirt. I won't put it down there. Yes, you will.
Best day ever, huh?
Just doing his thing.
Any other questions off of worksheet 11A?
23.
2-3?
Thank
You
you.
got it. So it's no longer a spider? It's no longer part of the arachnid?
Still,
You said 23, right?
Yeah.
Okay.
Eat it, Clay. I'll bet you 15 cents. Oh, okay. Hey.
You just made it?
Oh.
He's dead. Can you deny that?
Yeah, it's just, there it goes.
All right. We ready? Is the spider in a happy place? Did the spider become a bug because it only has 6 legs now?
Man, I think he's just pretty spiteful today.
All right. Let's start factoring a few things. So this is going to factor down to, let's see, 2x and x, and positive 3, negative 5. Did I factor that right?
Yeah.
Okay. And then, some of you are off task a little too much. So 2x and x, and let's see, minus 7 and plus 3. I think that's right. Did I get that? Think? Cool. And then this will break down a little bit further. So this is actually still part of a numerator. So it's, you could just kind of put it along with this. So I could factor a 3 out. So I have the singleton 3 I have to remember about. And that's going to be 2x plus 3. And then I'm going to multiply. Please notice I am changing the sign to a multiplication. So if I change that sign to multiplication, I need to have this become my numerator. So I'm going to factor a 3 out of that. And on this one, nothing factors out on that, just 2x minus 5. Does everybody feel comfortable with the math I have done so far? Okay. If you're having trouble with the factoring, come see me. We'll work with it. We'll get you better. Little trick I found with these is sometimes when you have like these single things out here, they become a factor of something else. Notice it's a factor of the numerator over there. Okay, so this is going to cancel with this. X minus 7 cancels with this. 2x plus 3 cancels with this. So I'm left with this 3 and this 3. So that gives me a 9. And then x plus 3. And there's nothing else in there. So there's my whole answer. Anything else we saw on 11A you would like to see? 8? What? 2-6, just for fun. You got it. 26 is kind of a review of some Algebra 1. And the one skill on this one, we are solving this because there is an equal sign. So we're trying to figure out what our variable is equal to. Okay, best thing to do on number 26 being is an equal sign. We want to solve x. I do have all these fractions, but you remember back in the day, you might have heard this if you had a pretty cool teacher. There was a term called clearing the denominator. Remember that?
Oh, yeah.
So we have 4 terms. And so I have 5, 2, and 4. So 20, if I multiply all of my terms by 20, Then you can reduce 5, that's a 4, so I get a 4 right here. Nothing to reduce here, so I get 40x. That becomes a 10, so that 10 times that's 70. And then that's going to become a 5, so that becomes a plus 15x. Is that okay? Nice thing about it is you no longer have to deal with fractions. Of course, you could have tried dealing with the fractions originally, but let's face it, I don't care how many times we see fractions done over and over and over again. No one really likes it unless you're a geeky math teacher. You're like, oh, I love fractions. So
Decimals.
I had a guy a couple weeks ago at church. He comes up to me. He goes, "Heard you're a math teacher." I said, "Yeah." "All right, what's 729 times 856?" And I'm like, 355,283. He's like, wow. And I walk away. And the guy all he knew is going, the guy just did triple digit multiplication in his head.
Is it right?
Said some
No! I just made it up.
The most thorough move.
I thought it was classic. I'm like, dude, oh, I heard you're a math teacher. I heard you're a doctor. All right, what's right here? I don't know. All right, let's see. Subtract 15x from both sides, so that's going to become 25x. Subtract 4 from both sides, so I get, is that 66? Is that right? Am I good so far in the math? Okay, root 66. Okay, and then let's divide. And I don't think 25 has any factors in 66, so I think that's our answer. And again, leaving improper fractions, in my opinion, in math is always appropriate. You never need a mixed number. Do we feel good about that sheet? Yay? Happy? All right. So if you got that done, or if you are part of the group that got goofed up because there was like this, mysteriously added addendum worksheet, turn in the A with whatever you wrote down. Make sure your name's on it. And if you're handing anything else in, I will not be collecting that worksheet. Oh, I apologize for the goof up on my part. Oof.
No, there isn't. Kate?
It's got Kate.
It's tickling my back and I don't appreciate it.
Any more homework over here? Any more homework over yonder? Or over yonder? Or over yonder? Hey, did everyone get one of the pages of notes? The notes? Lee, did I get enough back for you?
No.
Yay!
No way. No way. Hey, you're not leaving them out. Good job.
It only took 12 phone calls from his family. He's not even listening. It's like talking to my wife. All right. Addition and subtraction of rational expressions. Okay? So, when we add fractions together, you know that you want to have common denominator. So you would have done this. And that would have given you 3 plus 4 all over 6. Okay, does anyone else need to see me go through and do all of the common denominator? Of course, if you do it the stirrup way, the butterfly method is my favorite way. All right, moving on. All right, so to add or subtract rational expressions, we have to have like denominators. You add or subtract the numerators. Remember, numerator means it's the top. And then you place them over the common denominator. Okay, the denominator is the bottom part of the fraction. And then simplify if needed, so reduce if you need to. Okay? All right, so first one, rational expression. It looks like my denominators are both the same. So I just wind up with 9 over 3x. And then from there, I can reduce. Okay? Second problem, we are same denominator, we're just subtracting. So this would give me 2x minus 4 over x plus 3. I would leave it like this. Some people, depending upon your teacher, I don't know who this teacher is, but I'm just saying, might want you to have it in truly factored form. Okay? And then see if anything reduces. If it doesn't, leave it like that. I would accept either answer as appropriate, as long as it's reduced. Good? Moving on. All right, same denominator, so 5 over 5x. So this will become 1 over x. Because the 5s would reduce? Yes? All right, to add or subtract rational expressions with unlike denominators, factor each denominator, okay? Use the factored values to find the least common denominator, the LCD. Oh, great, we're into acronyms. And then add or subtract as before. Okay, so these we're not doing anything. What we want to do is we have to realize that this would break down to x plus 1, x minus 1. So in order to get common denominators, this would become my common denominator if we were to add or subtract them. So I'd have to make sure I multiply both the top and the bottom by x plus 1 on this one and go through it. And there's not really any math to do on these. It's just get the common denominator. Problem number 5. Recognize you can factor this to x plus 2 and x minus 1. Notice I still have an x plus 2 down here. So if my common denominator is going to be this, so on this one I'd have to multiply by x plus 1 and x plus 1. Let's just pretend I can write really well. Dude, our imagination is not that good, though. Seem okay so far? What else do we got? Okay, so this one, let's factor this down. So that becomes 2 and x plus 1. That stays as is. That's just 2x. And then this one right here, this is the same thing as x plus 1 and x plus 1. Okay? So all three terms have a 2. Okay? So 2 will be part of my denominator. Okay? I have an x plus 1 here, but I have a second one here. So let's make sure we take care of both of them. And so this fraction, I don't have to multiply this by anything to change over to the right denominator. This one needs to, oh, there's one last thing I need to add. Anyone see it? X, yeah, this x right here needs to come down here. So on this fraction here, I would multiply it by x plus 1, and then do that same on bottom. And then this one, I need to multiply by an x and an x plus 1. And an x and an x plus 1. And that would allow us to have the same denominators. Then you could go ahead and add or subtract them without any problem. Again, when we multiply and divide, we don't worry about the common denominator because. Okay, and again, I'm not doing the math. I'm just showing you this is my common denominator right here, my least common denominator. All right, so if we perform the operation here, I need to multiply this by a 3 and an x and a 3 and an x. That's going to give me 15x over 3x squared plus 2 over 3x squared. Put them together over one common denominator. And it is already factored. 15x plus 2 will not break down any further. This one looks like my common denominator is going to be 2x squared. So I'm going to multiply this by x squared. I'm going to multiply this one by 2 and an x, 2 and an x, and this one just by a 2. So then on top I get 1 times x squared is x squared, yay. And then here I get 2 times 2x, I get 4x. And then here that's a minus sign that comes down, and that's going to give me 6. And I guess you should see if we could factor it. Nope, x squared plus 4x minus 6 will not factor. So that's your answer.
Wait, why is the bottom 2x squared?
Because I had a 2, an x, and an xx. So I need to have the maximum number of x's. So that's where the x squared comes from. So that's where these two have to be multiplied by x. And then this 2, that means I have to multiply this and this by 2 to get that as well. So I want the same denominator. So what do I have to multiply 2 by to get to 2x squared? I have to multiply x squared. Okay? May I move on? Yeah. Yay. All right. X squared minus 4. Is that x squared plus 2x or x plus 2x minus 2? So this right here is the difference of 2 squares. So that's actually my common denominator. What do I need to multiply this one by to get to that? 2. I have this already, so what do I have to multiply by? X minus 2. X minus 2, and x minus 2. Okay, so that's going to give me 4x minus, so this minus comes here and distribute it, minus 3x plus 6. Do you agree with the math I did? Because I distributed a negative 3. And then that's over x plus 2, x minus 2. Do the math. 4x minus 3x is x, so I get x plus 6. That won't break down any further. X plus 2, x minus 2. Notice when I have things factored all the way down, I'm keeping it grouped as parentheses. I don't want to go cancel something that shouldn't be. Problem number 10. X plus 5 is already factored. X plus 1 is already factored. What do you feel my common denominator would be? What two binomials? What are my two denominators up there? X plus 5 and? That's my common denominator. That's my denominator. So I'm going to multiply this one here by x plus 1, and this one by x plus 5, x plus 5. So 3 times that and 3 times that, I get 3x plus 3. Negative 4 times that and negative 4 times that is negative 4x minus 20. 3x minus 4x is negative x. 3 minus 20 is negative 17. That's pretty much factored. Then I get x plus 5, x plus 1. The problem's done. Now this is around the time that we should get someone saying, when do we ever have to use this? Well, you'll have to use it next year in pre-calculus and in college algebra and business calculus and calculus and even some statistics. So I just gave you 2 to 3 years worth of knowledge of when you're going to have to use this.
What is business calc compared to college trade and college algebra? Is it like about the same?
Dude, I'm teaching this. What does it matter? I'll get you through it.
Which class should I drop? Business or college algebra?
Drop them all, man.
I would keep the college algebra because you're definitely getting the college credit. The college trade you'll get college credit for, but you won't get college credit for mine. So I'd drop the trade. Or hang on to it and just add me.
Yeah.
Just be a rebel for your senior years. Like, dude, I got 8 periods. You know, 9 of them happen to be math classes.
I don't know.
Now someone's going to be like, wait a minute. How can you have... That makes sense. I'm so confused. All right, number 11. I can factor that denominator. This is going to break down to x plus 5, x minus 6. Okay, so what's my common denominator appear to be? Yeah, it's that whole thing. So I get x plus 5, x minus 6. Okay, I don't have to do anything to this first one. It's already done. What do I have to multiply this second term by? X minus 6, good. And x minus 6. And I'm distributing negative 1 here and here. So I get negative x plus 6. Those x's cancel, so I get 6 over x plus 5, x minus 6. That's all done. That's pretty. I like that. And this is where these seem really complex and they kind of stink. But I'm going to group that, because those are already factored. So, let's ask you all this. What do you think, without putting a lot of really hard work and effort into it, what do you think this right here is going to factor into? I'll underline it and circle it in yellow, just so you see it. Okay, that's the kind of cool thing about doing some of these. Is like, dude, this problem sucks. I hate factoring. Oh, wait, I already have my 2 factors. So that's going to be our 2 things factored. Okay, so I'm going to get, this is my common denominator, which that's all that is that factored. So I'm going to multiply this first one by x plus 6, x plus 6. And so that's going to give me x squared plus 6x plus 2 is plus 8x plus 12. Multiply this second one by x minus 1, x minus 1. Make sure you distribute -2 to both of those. So I get -2x plus 2. And then the last thing I don't have to do anything to because it's already over the right denominator, so that's just minus 14. Does that seem okay? Combine like terms on top, so I have an x squared, then I have an 8x here, minus 2x, that's 6x, and then I have that and that and that, so that's 12 plus 2, which is 14. 14 minus 14, at least last week was 0. This week might be different. Okay, so I get that over x minus 1, x plus 6. Is the numerator factored? They both have an x, so no. So then I get x plus 6 over x minus 1, x plus 6. Does anyone see something that might cancel?
Yeah.
Yeah. X plus 6 is gone. So I get x over x minus 1. Man, this is some good nifty stuff. Probably give you like 80 of these problems tonight, huh? Dude, no. Can I move on?
Yeah.
Good, good, good. Woo! All right, let's extend the page. So this is going to be x plus 3, x plus 3. This is going to be x plus 3, x minus 3. And then I just have this x minus 3 right here. Oh my gosh. So I have x plus 3 and x plus 3. I have an x plus 3 and an x minus 3. And I have an x minus 3. So what's the maximum x plus 3s I have? I have 2 of them. So I have that and that. And then I also have an x minus 3 that we have to bring into the mix. Yuck. All right. Let's change.
Wait, Mr. Sharp, why does it only have 2 x plus 3s?
Well, you have 2 here, you have 1 here, so you don't have to repeat it. I repeat it because I have 2 of them here, but then I have the x minus 3 as well.
Oh.
All right, so this first one, I'm going to multiply that by x minus 3 and x minus 3. So if I FOIL this out, I'm going to get 2x squared minus 6x plus 5x minus x minus 15. Good. This one right here, I have to incorporate another x plus 3 and another x plus 3 for top and bottom. So let's multiply that out. So positive x times that, I get x squared plus 3x. And then this one, I need to have a x plus 3 and an x plus 3, both top and bottom. So if I multiply that out with the 1, I'm going to get x squared plus 6x plus 9. That's just frightening. That would make young children run. All right, so I have 2x squared, x squared, x squared. That's 4x squared. I have negative x. That's 2x, 8x. 9 minus 15 is negative 6. And that's all over x plus 3, x plus 3, x minus 3. I guess I could factor a 2 out of everything on top. Over x plus 3. X plus 3. X minus 3. Ooh, and something I don't know off the top of my head. Does 2x squared plus 4x minus 3 factor? I don't know. Plus 3 minus 1. That's it. Oh, what kind of jerk gave you this problem? Bless you. So I'm going to replace that right here. Do we have something the same on top and bottom? Does anyone see that? I think I have an x plus 3. So this is going to cancel one of those. So then my overall answer is, I Man, I can't believe some teacher gave this, man. That's just sick and wrong. All that work, man, that's like 3 TV shows worth of math all in one problem. That big jerk gives that kind of stuff out. All right, yeah.
I don't think that factor is right.
So 2x times 3 is 6x. It doesn't. Okay, so keep that and keep that. So that's keep it and keep that. So this is my answer, and that's Ding Dong Stirrups' answer. All right, how many more slides do I have to get through in 2 minutes? 19 pages. Oh, just that? Holy cow! I can't believe I made it there. All right, so I saved the best for last. So if you've already hated fractions, now we're going to create complex fractions as fractions, which means I have fractions over fractions, which this is just not nice. So I'm going to make this 8 over 8. Are you still with me?
No.
8 over 8 is the same thing as 1. So I'm going to go 11 over 8. Still with me?
Yes.
Okay, I'm going to make this 4 over 2. Is that okay?
Yeah.
So 4 minus that, so I get 3 over 2. Multiply by the reciprocal. 1, 4. Looks like that. Ew, yuck, gross. Oh, I still got a minute. I can do it. I'm going to make this 8 over 4. So that's going to be 5 over 4. Over. I'm going to make that 9 over 3. So I get 11 over 3. Multiply by reciprocal. You know, the hardest concept, of course, we fly through as fast as we can. So, I would say worksheet 11B, but.
Evens.
Okay. Evens.
Yeah.
Cool?
Thank you.
See you guys later. Take care of one another.
Right.